Hello, and thank you all for joining us for this Education Transformation 2020 presentation, Addressing Individual Differences in Teaching Mathematics. My name is Julia Lyman, and I am on the Training and Support team here at Hawks Learning. Our speaker today is Professor Solomon Willis of Cleveland Community College. Professor Solomon Willis has been teaching math for 21 years. He recently finished a Specialist of Education degree in Mathematics Education through Nova Southeastern University, and is currently working towards an educational doctorate degree in Curriculum and Instruction at Liberty University. His experience includes teaching anything from Algebra 1 in middle school to Calculus 2 in college. He is a big proponent of using active learning and technology in the classroom. We are so excited that Professor Willis is here to share his experience and insight with us today. We do have a large audience, and we'll do our best to get as many questions as possible during the presentation. Victoria Kelly of our Hawks Training and Support team will be joining us in the background of the webinar today. She is here to help answer questions throughout the webinar. So please enter those into the Q&A as we go, and she will write back to you. If you have questions for Professor Willis, we'll save those for the end of the presentation. And on that note, I will hand it over to our presenter. The floor is yours, Professor Willis.
All right, well, thank you so much. And thank you for everybody joining in today. I know this is a busy time of the year for everybody just getting started back with their fall semester and everything. So I appreciate you taking out time today to listen to me, and I hope I have some good tips and tricks to tell you about things you can do with your students. Now you're probably looking at that and saying, well, he's from Cleveland Community College, you know, and I found when most people see that, their mind goes to Cleveland, Ohio, but you hear me talk and you know I'm not from Cleveland, Ohio. I'm actually in North Carolina, and that wording is Cleveland County, North Carolina. So I'm in Shelby. We're about an hour west of Charlotte, and actually right now with the situation everybody's in with COVID and all, we're doing about half face-to-face and half online instruction for the time being. So we're kind of playing it by ear, and you know, just seeing how things go with that. But we just started this week, so I know this is a busy time for everybody. So anyway, as that was a great introduction, by the way, as she said, but I've been teaching about 21 years. I started in the high school setting and then later kind of moved in to college teaching, but I still work with high school students pretty often through some of our dual enrollment programs. It's not uncommon for me to teach like a section of pre-calculus in a local high school. And actually that's just where I came from right before I started this. It was my first day with a group of high school students about 10 minutes away from here. But anyway, she mentioned my degrees, and I always just like to give a plug for Appalachian State University, just in case you were looking for graduate credits, or you know somebody who is, because like in our case, we have some developmental math instructors who only have the bachelor's, and so they're looking to get the master's so they can teach the college transfer courses. Or have had some folks that had a master's degree and they just needed the 18 hours, you know, to be able to teach math. And so I always like to give a plug for Appalachian through their MELT program. It's melt.appstate.edu, and I've got the URL there for you. They have a great summer program, and of course this year was the exception to the rule, but normally in the summer there is a way to go there and take a class in a week and earn 2 graduate credits. So that's actually how I started my master's degree, was through that program. And the first summer I earned 8 credits through 4 weeks of classes, and it was intense, you know, I'll be honest, it was intense through that time. but it was a good way to knock out some credits. And then they are great with their distance education programs. They're doing more and more online stuff. So I just always like to give them a plug. That was in the early 2000s for me. And then as she said, if you're looking to go higher than that, Nova Southeastern has a great specialist program in math education that was all online. And then I found out it was a pretty smooth transition to transfer a lot of those credits into Liberty. So some of that I really had to look for, you know, till I found the right fit. But I can tell you all that's gone very well, and I've been blessed with all that. And that's something else, you know, I'm happy to talk to you more about if that's something you want to contact me later about. So anyway, the reason you're all here today, individual differences in learning mathematics. And I will tell you, this actually started as an assignment for one of my specialist classes. And then I just sort of, you know, kept adding to it and eventually turned it into a presentation. So here we are. But that just kind of shows you the different things that I'll be talking about. It will end up with like some graphing calculator type stuff and some of the active learning projects that I use in our statistics classes here on my campus. So, you know, the first thing that I start with here is just talking about how everyone learns math differently. And if you've been teaching a while, you know that, and you've heard about multiple representations and all that. And when you've got a big class, it's hard to cater to all those different learning styles. And we certainly do the best we can, because there is a lot of differences in one class. And, you know, the push now is that teachers are, you know, facilitators more than lecturers. They don't want a section more than 20 minutes at a time. So I try to, you know, go back and forth between direct instruction and group work and technology and all that. And so hopefully I'll hit on something that everybody can relate to, you know, in that 90-minute time block or however long that I have. But no matter the situation, various learning styles are going to exist. That's just the nature of the beast. So, so the next thing here is that I'm sure you've heard of the myth that males do better than females when it comes to learning math, and that's kind of been a myth for a long time. But if you look at the research, there's actually more out there that says that that's not true than it is. And they have found that really what it is, the females just show more test anxiety, and math anxiety is really kind of where the issue is. So, you know, just helping all students feel comfortable in our classrooms is important. I think it's good on the first day just to get to know your students a little bit and help them feel at home or whatever. And, you know, even just today, the group of high school students I just left, as an example, it was a small class. And we just kind of did orientation today, but it was a small enough class. I just let them all tell me, you know, what their plans were. They're all high school seniors. And so they were telling me about where they wanted to go to college or what they wanted to do next. And, you know, when I told them my backstory with how I ended up being a math teacher, you know, I saw a few smiles because I set out to do something else and switched to math later. So I was just saying, you know, to follow your heart and what you like to do. But I think, you know, there's some educators will tell you jump straight to content on that first day, but I think it's important to try to get to know your students a little bit. Of course, in this day and age, we have, excuse me, a lot of computer software to help with like adaptive learning and personalized learning. That seems to be a big trend excuse me, right now. And I have to give Hawks Learning a plug right here, because I will tell you that last the last school year, last fall, I had to teach a section of Calculus 1 totally online. And I was a little taken back by that, to be teaching a course at that level in a totally online setting. And I ended up using Hawk's calculus textbook along with their courseware. And I have to give them, a plug for that it was like one of the best software packages I had ever worked with the way it has the three learning modes and certify and all that. The students really liked it. It was very self-paced, and it catered to their strengths and weaknesses. And this is by no means meant to be a commercial for Hawks, but if you ever find yourself in that situation, it will save you a lot of trouble because a lot of the stuff is already there for you, and it's really user friendly for the students. But with all of it, because we use different platforms for different subjects, and if you've been teaching a while, you know the difference from just working out a pencil and paper all the time. So my students like the immediate feedback, and I like the automatic grading. So if you've ever been reluctant to some of those things, I would encourage you to look into it. And I might have got off track just a little bit there, but anyway, the next thing here is ethnicity. And again, differences are sometimes associated with socioeconomic status rather than ethnicity. It's another misconception. Findings from a study indicated that schools with more low-income students required the most support in structuring equitable policies and practices for mathematics teaching and learning. That's a mouthful right there. But sometimes language barriers may exist. It may not be the math itself. It may just be a language barrier. And literacy and language are also important in a math class. And, when I first start thinking about these things with my own experience, I will tell you that here on our campus, we have an early college. We have, like I say, we have classes where sometimes we go out to high schools, but we also have a high school component right here on campus through the early college program. And I have taught math classes that was strictly just for those students, and then I've taught them where they were mixed in with my other students. And we have been told before that 85% of those students are on free or reduced lunch in the county. And I have to tell you that if nobody would have ever told me that, I wouldn't have known it, because they have been some of the best classes that I've ever taught. And it's not that they're, the students with the highest academics or whatever in the county. That's kind of a misconception. There's some people say, oh, well, just the smart kids go to the early college. But it actually targets first generation college students or students in the county that may not have a chance to go to college any other way. But I will tell you, they do well, and even with transfer scholarships, I think they've set records before with like how much money they've earned collectively to leave from here to go somewhere else. So, it's important not to ever judge anybody just because of their ethnicity or socioeconomic status or any of that. And with the language barriers, I'll tell you something else that happened when I was teaching at the high school level, and this has been a while ago, but we had two foreign exchange students from Korea, and they were very nice, very well-mannered young men, but there was a strong language barrier that existed with them. And, after just a few weeks in our school, word was kind of getting around that they were having a lot of problems understanding some of their teachers. But they could do algebra because apparently, the way you solve an equation or whatever, whichever language you're working in, it's very similar. So they already had some math experience from Korea, with algebraic concepts, and we're doing real well. But one thing that always stuck out in my mind is on one of the first tests that we had in that class. You see my question there, and these probably weren't the exact same numbers I used at that time, but they had to arrange the numbers in order from least to greatest. And you see there, it's not just, whole numbers. So they'd have to do a little bit of computation there to know which is least to greatest. But, one of these students looked at that and didn't know the wording, least to greatest. And so he comes up to my desk during the test, and he writes down on a paper 1, 2, 3, and then he writes 3, 2, 1. And he asked me which one is least to greatest. And so I pointed, at the 1, 2, 3. And once I did, he knew exactly how to answer the question. And I just thought, that is incredible. I mean, I would never have thought to ask my teacher something like that, if I would have had a language barrier and didn't know which way I was supposed to go with something. So that just really resonated with me, and I love telling that story that he came up with that all on his own, so he would know how to do that problem. But they did well, and this was an Algebra 1 class back in the day, and anything that was symbolic or just straightforward, they did very well with, and but still struggled with word problems. And my joke was, well, the students that can read the word problems, they struggle too, so it's all good. But I did say that if they did fully understand those word problems, they could do them too. And so we would work through those challenges, as we move through the course, a lot of interaction after school or before class, early morning, all that, And it wasn't just them, any of them that needed help, we would do study groups. It was a private school, so it was pretty hands-on with the students and parent interaction and all that. And that kind of leads into the next thing here, students with disabilities, kind of the same thing. If they've got learning disabilities, sometimes just a few extra minutes before class or after class can make a world of difference, because some of, even if it's just a learning disability that nobody else really knows that they have, they might be too ashamed to ask, in front of everybody. So I encourage mine. I always say, please stick around if you've got questions. I'll stay till the last person leaves. So, as long as I don't have to rush off to another class. But a lot of times I have found that when I'm helping a student work through a problem, one-on-one, they really just need somebody saying, yes, you're doing it right, keep going. They need like a little cheerleader, just a little motivation. And 9 times out of 10, it's not really the math itself. They just want to know that they're on the right track, or that they're getting started the right way, and I say, yes, that step is right, keep going. And that just really resonates with them. And all students, I still, this probably comes from teaching middle and high school, but I still give out stickers and prizes and all that. And I say the big kids like that as much as the younger kids do. So even I'm at a community college, so the students that are returning to school, they like that stuff too. And in fact, when I started out teaching here, I was younger than most of my students. So that was a little bit of adjustment at a time. But when I was looking down this road before, or first working on this, I like to quote that I found. You see there with the 4th bullet point where it says, help the students feel enabled by math rather than disabled by math. And so that, I just liked how that sounded, just for motivation and helping them know that that they can do it. And of course, repeated practice is beneficial in any math class. And one other thing that I thought of that's not on here, but a few years ago, we had a blind student on our campus that needed to take an algebra class. And it was actually a part-time instructor that was teaching the class, and I'm the chair, so I have to make sure everything works the right way. And we were talking about, how are we going to get through to this blind student when they're trying to graph a line or something like that. And so we found these pegboards online. I think it was through NASCO, and it was like these little pegboards that were set up like a Cartesian coordinate plane, and it came with rubber bands and things that they could use to do the graph. And so we looked at it, and we were going to have to order 20, just to get one. And so the instructor was like, well, let's just use it with everybody. It's like, why just have the blind student use the pegboard? Everybody in the class can do that. And so she did, and it was just a big success too. So still to this day, even if, there's not a blind student in the class or visually challenged, she uses those pegboards. And, even at the college level in a developmental class, that can be beneficial. So I had to give her credit too, for embracing that, being just a part-time instructor. But as soon as we find out something, we do what we can to help everybody be beneficial. So another thing, and this resonates with all students too, not just the one with learning disabilities or whatever, is graphic organizers. And I'm sure some of you have heard of that. And I think at one time that was mostly associated with the younger grade levels. But, excuse me, you'd be surprised what you can find out there, especially in this day and age. If you just do a search, for algebra graphic organizers or whatever, you can find something like this to help represent functions is what they're doing in this example. And there's a lot of stuff out there that's free if that's something you would like to use. So when I've used that with students, I would sort of help them fill in one. We'd do it as a whole class, and then sometimes they would break into groups and do more of those, and then eventually be able to do one on their own. Because in the North Carolina Community College system, in our math classes, we have lecture hours and lab hours. Most classes are 3 lecture and 2 lab that meet, 2 or 3 days a week. So we do a lot of active learning in those lab times. So just another idea there, it's useful, particularly if they have learning disabilities, but everybody can benefit from that, especially if they are a visual learner. All right, and so this next one is just talking about strategy preference, especially like when you're doing word problems or applications and things like that. And there's something called the concrete representational abstract strategy, the CRA. And of course, the C, or the concrete, is hands-on materials. The representational is the pictures, graphs, and tables, and then abstract is the numbers, variables, and symbols. And so I'm just going to I'm going to come back to that screen in just a minute, but there's an example of kind of what I'm talking about when, especially like in an algebra class or even pre-calculus, when you're talking about the concept of a function, you eventually want to get them to a point where maybe you start with something numerical like that, but you end up with a plus a equals 2a, and so you're showing a concept that adding a number to itself is the same as multiplying that number by 2. And so, with other things, those of you that teach calculus, I'm sure you remember where you can plug in like 10,000 when you're trying to see what a limit is that approaches infinity, and things like that. So at any level, you can put those tips in place, or those practices in place, I should say. And even with that, like with the hands-on materials, when I've taught a developmental algebra class, I still pull out the algebra tiles. I had those when I was in a high school, and not long after I got to the community college, I asked them to order some for me, and they did. And so we still use that when we're working with polynomials. So I say the big kids like that too, or the base 10 blocks. And then they don't have to be fancy. Things as simple as playing cards and toothpicks and candy is beneficial too. The M&Ms, there's all kinds of things you can do with that. I'm sure a good many of you have heard of that before. You know, whether it's something as simple as comparing a percentage, you know, in the lower class up to doing a confidence interval in a stats class. But again, the amount of activities we can find online is pretty much endless in this day and age. So I like to take time to do those things too. All right, so that was just what I mentioned before about the going from numerical to symbolic. That was just a nice little graphic I found one time. I think when I was initially putting this together about going that direction. And so another thing here, and this will kind of get into the technology piece too, that that I'm about to show you. But problem solving here, if you've got a problem like this where you've got a car rental agency, they're charging $180 per week plus 15 cents per mile to rent a car. So how many miles were driven during the week if the weekly cost to rent the car was $243? And, you know, to somebody that's not a math major, that just sounds terrible when they read a problem like that. But algebraically, this is usually how we want our students to do it, especially if, you know, we're trying to teach them to set up more difficult situations later or something more involved than that. But you know well as I do, some students would rather just do this right here, and they'd say, well, I can do that without doing any algebra, you know, just subtract 180 and find the difference and then divide that by 0.15, and they say I get the same answer. Well, roughly they're doing the same thing up here. I mean, we're representing that symbolically, but it's the same kind of math as they work through it. So I don't think there's anything wrong with doing it numerically, but you want to lead them into doing it algebraically because of things to come. And a lot of times stuff like that, I even say, well, let's just talk about what that is in plain English before we put the algebra into it, or before we make it symbolic. And I've done that before, like with increasing and decreasing on graphs, you know, like where's it going up and where's it going down, and we got to read it from left to right and all that. So a lot of times that I do just talk in plain English before I do it, you know, the way the textbook would say to do it. And one thing I caution my students on, especially with that second method, I'm sure some of y'all seen this before, but if they forget to put the parentheses around the 243 minus 180, they're going to get a very different answer. And I often show them that with the calculator, that they need to be sure to put the numerator in parentheses if they are trying to do it all in one step. And y'all know how some of them would do that. So it's easy to make a mistake. So that kind of leads in more to the technology part of this, and I am a big user of the TI-84 graphing calculator. I've used it since it was just the 83 before the 83 plus even came about. And I kind of went through high school when those were starting to get popular, and I think like by the time I was a senior in high school, everybody had them. And so I was eventually taught with one, and I've always been a big user of that. And the Appalachian thing that I mentioned at the beginning through the MELT program, a lot of that centers around using graphing calculator technology too. So anyway, with this one, excuse me, I had to get a sip of water there. But one of the classic representations of a quadratic equation or polynomial equation here is, y'all have all heard of this, the classic problem where you throw a ball up in the air or off of a cliff or something, and this one is at a height of 5 feet off the ground, And it's modeled by that equation, negative x squared plus 4x plus 5. And of course, I've simplified that down. You're probably used to seeing a 16 there most of the time, but for this one, I've scaled it down a little bit. And so the problem is asking what is the maximum height and when does it hit the ground. So, you know, we all know how to do that algebraically with finding the zeros and finding the vertex and all that good stuff. But I like to show the students here the different representations that the calculator can show them. You know, with the symbolic, they have to be able to key that in the right way. And the numerical, if you press second graph and go to the table, you see all the zeros, and they like looking for that. And then, of course, I've got some images there of what the graph looks like. And I hope in this next screen I can show you kind of how that works. I've got a little animation here. We were going to try to do this with my emulator, but we've had trouble going back and forth between the PowerPoint and the emulator. But this is the TI-84 emulator that Texas Instruments has, and I'm a big user of that too. So what's going on here, let me see if I can play this animation. So I've got my equation typed in, but you can go over to the left, and that's what I'm doing. If you take the cursor and go over here, you can change that to a line with like a little circle on the end. So you see it there, and then if you press the graph, they can see that line drawn across the screen, and the students really think that that's cool. So I would encourage you to show them that, and it's like they can see the ball being thrown up in the air and hitting the ground. And then from there, with the graph, you know, you can find the maximum, and I think it's going to start over by accident. I apologize, but you can see that one more time, the line with the little circle on the end. So there it is. But then with the technology, they can also find the maximum and the zero. So if you go second trace and you press number 4 for maximum, you get that cursor, you know, a little bit to the left of where you know it ought to be, and then a little bit to the right of where it ought to be. And then you just press enter. You don't have to guess, and there it is. So that maximum is at 2. And of course, you have to tell them about the round off error. But that next one, I did the zero function on that one to find where it hits the ground. So once again, you get that a little bit above it and a little bit below it, and then it will tell you about where that is. So it's at 5. 5 seconds later, it hits the ground. With the scientific notation, but I'd say, well, that's close enough to 0 that that's just 0. So you can always explain how it's using a numerical method to do that. But they really, you know, like things like that. And if this is not something you're as familiar with yourself, you know, there's plenty of resources out there if you just search for it, or even YouTube videos and all that. And if all else fails, you can contact me and I'll send what I have. All right, so with the technology, some of y'all's gonna grant at this probably, but just wanted to mention another personal connection that I have with students. I don't know if you can see the pictures around me or not that's in my office, but I'm a big Dolly Parton fan, and everybody knows that about me. Everybody I went to school with, and even here on campus, if somebody can't remember my name, they'll say, oh, well, I had Dolly Parton, and I couldn't think of a better way to be remembered. But even in a statistics class, I've used data like this to illustrate some of my examples. And this was her chart singles through the 70s. That was kind of her heyday. And I say, you know, there was a time when Dolly was like the Taylor Swift of today. You know, we'll talk about in the 70s when she had Jolene, and then 1980 when 9 to 5 came out and all that. So they usually get a kick out of this. And so that's just an example of a of a time series graph of her hits, and I say, this is more fun than temperature data, so we'll just look at this. And then I'm going to share a project with you here in a moment where they, get to incorporate some of the music that they like as well. All right, so the next slide here again is just saying a few more things about motivation. And there again, if we have a positive attitude, that seems to resonate with our students. And if we don't like something, they're not going to like something either. So, let me go back. So I try to always go in with a positive attitude. If something is wrong, I'm not going to let them know it if I can help it. But helping them feel comfortable, helping them not be embarrassed, and all that good stuff, just really resonates with them. And I'm having a little bit of a technical issue here. I hope this is not about to freeze up on me, but okay, I'll keep going. I guess somebody will tell me if something's wrong. Let's see where to respond. Okay, there we go. All right. So really the last part of this is just talking about some of the projects that I give in Math 152, and that's our introductory stats here in North Carolina, community college system it is. And so I was talking about my interest in Dolly before, and I let the students tell me a little bit about their musical interest. And so one of the first projects that I give in my statistics class is they create a database of like 30 songs from their iTunes or Pandora or whatever they use to listen to music. And we talk about random sampling and systematic and all that. I let them choose how they're going to collect the data. And then they do they compute the lengths of each song in seconds. And then they run, all these statistics on those 30 songs. And we make a frequency table. Sometimes we do a histogram. Other times I change it to a frequency polygon, and just a lot of the stuff that's in the first few chapters about descriptive statistics. And then they, get to share that with their class. And we talk about the shapes of the distributions. If hardly nobody's is symmetric, there's a lot of skewness, and we talk about which way that ought to go. If they're using older songs, they're mostly just around 3 minutes, but the newer songs are around 4 to 5 minutes. So the different graphs, go different ways just based on the music that they're working with. And this is, you're seeing a screenshot of part of the guidelines. It's a little bit more than that, and I believe in the materials they send out after this is over, you'll have a PDF that has all of this in there if it's something that you would like to use later. And of course, you can also contact me here at the college if that's something I can help you with. But the second project here, I call it pizza and sandwiches, and I tell the students that they're going to need a takeout menu from an Italian restaurant or Pizza Hut or somewhere to be able to do this. And that usually gets some strange looks because they don't know what it is they're about to do. But I call it my Olive Garden example, and I refer to, like when you hear a commercial about the never-ending pasta bowl, and they say, we have 120 combinations on the menu for our never-ending pasta bowl. And so I tell the students, that doesn't mean you sit down at the table and you get a book with 120 different things in it. And I joke and say that's at the Cheesecake Factory where that happens. But at Olive Garden, the 120, is from multiplying those different choices together with the pasta and the sauce and the topping. That's how they're coming up with the 120. So this project kind of mirrors that, where they talk about how many different ways a sandwich could be made, or a one topping pizza. And they're really surprised sometimes at how high the number goes. Some of them that use a Subway menu can even get it up into the millions, I think, or over a million. Just talking about, if you think about all the different options with the bread types and the toppings and the meats and like that. But they really like that project too. They make a list of the different possibilities, and then they count those and multiply them together. It's not nearly as intensive as the first project, and they're taken back a little bit by that, because the first project is probably the hardest for them, as far as the amount of data collection that they have to do. So the third one, and there's just 4 total. So the third one is when we get up to the binomial distribution, and we simulate what happens flipping a coin. If you flip a coin 4 times and you're counting how many heads you get in each of those 4. And so they do 20 trials, and they do 4 tosses in each trial. And so I tell them, I say, you can be old fashioned and with the coin and actually do this. Or I tell them they can simulate it with the graphing calculator or with Microsoft Excel. And you can't see it on this screen, but further down in that document, I've got the instructions on how to simulate with zeros and ones, how to do heads and tails. So those step-by-step instructions are in that document. Just look in the PDF that they send out if that's something you're interested in. But we compare that, the experimental probability, to what the theoretical probability says that it should be. And they make histograms of each one. And I tell them that the first histogram, everybody's is going to look different based on their experiment, but the second one, everybody should look the same if they do it the right way. The first is the experimental, and the second is the theoretical. Is the way that I run it. They make a frequency table and everything, but most of these projects build, on stuff we've done up until that point. And then the fourth project here deals with the normal distribution, and this one I give them the data to work with. So this is the only one that everybody's is the same, and it's the easiest one for me to grade for that reason, because all the others, everybody's finding their own data. But it just, they make a histogram, and they'll see that data set there resembles a shape, symmetrical shape. And then again, we compare like how many scores actually fall below a certain number compared to what the normal distribution says that it should be. But we went through a big redesign in North Carolina a few years ago, and they wanted, more active learning strategies put into this stats class. And that's kind of when I started coming up with these. Most of them I got the initial idea from a textbook. I didn't just come up with all that myself. And if in the PDF you'll see the references page where these were pulled from. They're my own variation of the projects, but I can't take credit, for creating them from the ground up. And on my campus, I've taught these courses in a number of ways. I mean, it can be a 16-week hybrid class that I see them one night a week. It can be a 2-day a week, regular college class, or it can be 11 weeks in a high school. If it's that, it's every day of the week. So if I have, more face-to-face time with the students, especially in the high school settings, some of these are just classroom activities, and they work real well with students. Or if I don't have a lot of time, it's like in the hybrid classes, then these are projects that they do on their own. We talk about in class, you know, how it should go and all that. But I've used them all different kinds of ways. And there's another one, even based off that music project. There's like a part 2 to that project where they do a little bit more after we get into standard deviation and more of those things. And the normal distribution, I've got 2 variations of that one. This one has age data, and I've got another one that it has grades from a final exam. So the kind of work that they do is the same. It's just a different data set up at the top that that I have them to work with. So that was the last part of that, and that's really the last thing that I have there. So I was going to see if Julia, do you have questions or something else there we need to do?
Hi, thank you all for attending our webinar today. Thank you, Professor Willis, for a wonderful presentation. So what we'll do now is we'll open up for our questions and answers. So if you have any, please keep them coming through the Q&A chat. I'm going to go ahead, and I actually see a couple of questions here. I have Andalena. She wants to see the song project again. So if you could go back to that slide to show her that one.
So that one right there. Okay. Yep.
All right. So just to let everyone know, those projects will be available for download once we have everything uploaded for the webinar. So we will send those resources out to you as well. I think that was also one of her other questions as well, was to get a copy of all the projects. We will have those available for you all. Mm-hmm. All right. Okay, I'm just going to give us a few more minutes if anybody has any questions. All right, I do have a new question from Leslie Martinez. Do you ever measure math anxiety in your classes, Professor Willis?
I haven't, but not formally. But I'm going to, as part of the research that I've been doing to finish up my doctoral program. I'm going to use there is a measurement scale that I'm going to be using to do that. But I just you know, informally, I mean, I know that it happens. I mean, I've literally had students, you know, shaking to come up and ask me a question. I'm like, well, why are you shaking just to come talk to me? But it would usually be, you know, somebody that was older and returning to school. But I just tell them, you know, that I'm down to earth and here to help them with that one step along the way. We're not trying to turn them into math majors, and most of them won't. They're just wanting that one math credit to get their college degree. And I say, well, you probably feel like me when I was sitting in a history class or a psychology class when I'd rather been taking a math class. So I not measured it formally, but I will be over the next year.
All right. Our next one is, what type of testing do you prefer? And this is from Alexander Diatkar.
Well, traditionally, of course, this semester is different, but the classes that are face-to-face, I still give paper-based tests, and they usually have a mix of multiple choice and free response, and that just comes from me teaching AP for a while. Back when I was doing some high school math, that's kind of how those exams are structured. In the online setting, I don't require a lot of like paper or scans going back and forth, just because it's so time consuming, and it's easier just to use the technology. And of course, this year we're encouraged to be as paperless as possible, but typically I'm old fashioned with my tests. They're paper and pencil, but it just depends on the setting too. If it's been a class that we just meet one night a week, I usually just give a midterm and a final. But when I'm doing a high school class where I see them every day, I test more often.
Thank you, Professor Willis. We have another question. Can you show us again how you get the circle to graph quadratic equation by hand in the calculator?
Yes. So let me get back to, let me sort of tell you before I play that animation, but typically your cursor is sitting right here where you see the negative x squared. And so you left arrow, go to the left of that y, and you press enter until that changes into the one with a circle. And then once it does, you press graph. And so this is what that looks like. So I'm going backwards there. I'm pressing enter till I get the one with the circle. So there it is. And then I press graph and there it goes. So that slows it down so they can see the graph going across.
Thank you, Professor Willis. And we have a few more minutes for questions, so I'm going to go over a couple other ones. Our next one is, do you have the students download the emulator, or do they use a physical calculator?
The majority use a physical calculator. We have those available for purchase in our bookstore. The emulator is primarily for the instructors. My college has a site license to that, but it's just for the instructors. I've had a few students that have wanted it for their laptops, but they would have to buy and purchase that themselves. Some of my more tech savvy students have found, like, unofficial apps on their phones that would have like the old version of the 83 on it, but for the most part they purchase and use actual calculators.
All right. One of the instructors previously, Leslie Martinez, who asked about math anxiety and the testing, she wanted just to tell you that was excellent, and she does research in math anxiety, and she has some preliminary results at the university level. It says we're at an Hispanic serving institution, and she would love to connect with you about that.
Oh, wonderful. Yes, please do that.
And one of our other questions, what types of active learning activities or projects did you do in the Calculus 1 class? Do you have a resource for finding ideas?
I don't have as good of a library of those as I do for like the stats. I teach a lot more stats than calculus. We're so small that we're lucky to have a calculus 1 to make in the fall, and then a calc 2 in the spring. So I unfortunately don't have a lot of resources for that. It's more of a statistics and algebra type thing. But with those, I've used more animations and applets and things like that I could find online. So we've gone that route more with the calculus classes.
Okay. And the next question, how do you assess individual differences?
Really just by the reactions a lot, but on the first day of class, I do have them to fill out like an inventory sheet that will ask them about things like that, like when was their last math class, or what are they going to take next. It asks about, are they a visual learner or audio or hands-on, or, which do they prefer? So I get some feedback from that up front, and then just informal discussions or observations from then on. And I say that I usually move with the class, as best as I can, and try to cater to what the majority seem to resonate with.
Thank you. And the next one, can you say something about the anxiety scales? Are these are these self-reported anxiety levels from 1 to 10, for instance?
I believe it is. I have to be honest. That is actually something that I am just diving into with the scale, but it is self-reported, and it is something like that with the scale. I don't know off the top of my head which one it is. I don't have that handy right at the moment, but I do know that much about it, that it's going to follow that path.
All right, thank you. I do have a comment from Shauna Simpson Singleton. She said, FYI, I still give my adult learners stickers too. They love Sminsels as well.
They do. They like that. I've taken stuff to, if sometimes, especially with the high school groups, because we use Blackboard, and if I've noticed that somebody, was poking around in Blackboard before the class would even start, I've taken a sticker or something and awarded them with that on the first day of class.
That's good. Our next one, can you share the quantitative results of the math anxiety study when they're available?
Sure, I don't see why not. Just check with me in another year or so, and I may have that ready.
All right, thank you. The next one is, do you let your student use a graphing calculator such as TI-89 during the test?
Not a TI-89, because I have personally felt the 89 does too much for them. But I will tell you, in some of my classes, it depends on the concepts at the time or which class it is, but I've given calculator active and inactive portions of tests, kind of along the lines of AP. So they would do the part first that lets them use a calculator, and then they would do the part that doesn't, because it's kind of like, if you're learning how to graph, you probably shouldn't use a graphing calculator to take that test. So we do a little bit of both most of the time.
Okay. Our next one, for the stat class, can you mention or tell us good resources for teachers and students?
Yes. Let me think about that. There's actually, in North Carolina, we have an NC-MATIC. I'm sure some of you've heard of AMATIC. That's the Math Association of Two-Year Colleges. And on our NC-MATIC site, if you just search for that, there's some course-specific resources, and our stats is Math 152. So if you look for MAT 152, I know there's some stuff on, I believe it's still there. It should all still be there. Resources for that. And then back when, this comes back to my days of doing the AP stats, there was a textbook by Roxy Peck that had a pretty good like ancillary notebook that had a lot of activities and stuff in it, and I still pull from that even till this day to find stuff to do in the classroom like that. But a lot of it is just a web search, and I find that just searching by topic, I even tell my students, if they're looking on YouTube now, if they just type in statistics, it's the needle in a haystack. But if you type in, binomial distribution activity, I almost guarantee you'll find something, and probably more than one thing, and find something to use pretty quick and easy that way. So just searching by topic is my recommendation for that.
Thank you. And we have one last question. Is it possible for a test to predict that individuals will have lower or higher exam performance? What are your thoughts?
I believe some platforms do that now. I'm not doing anything like that myself, but with the personalized instruction and all that, I believe there's the things that could do that. When I used the Hawk software with the calculus, it definitely would show me, where the strengths and weaknesses were of the class and things like that. But I don't know if it predicted test performance. So I haven't used that myself, but I believe those capabilities are out there.
All right. Well, thank you so much, Professor Willis. It looks like we're just about out of time. We have a lot of thank yous and especially a lot of thank yous for the valuable information to help rev up their teaching for this semester. So what we'll do now is if you have any other further questions that may come up once we end, you can always direct them to us at marketing@hawkslearning.com. We will be emailing you a link to view this webinar on demand shortly. So I hope everyone has a great rest of their day. And once again, thank you so much, Professor Willis, for joining us today.
Well, thank you too, and I appreciate everybody taking time out to listen to me this afternoon.
All right, well, thank you. Bye.